Okay, so today we're going to be talking about trigonometry. As it says here, first we're just simply talking about the ratio of the side lengths of a right triangle. So, you know a ratio is just a fraction. So all we have to do is talk about what is it that we're going to put into ratios. Well, we're going to use these terms: opposite, adjacent, and hypotenuse. You know what the hypotenuse is. It's the side that's opposite from the 90-degree angle in the triangle. So in this triangle, whether we're talking about angle A or angle B, the hypotenuse is always going to be AB. Right? Now, how do we know that AB is opposite from angle C? Well, if you trace the two sides of the triangle that make up angle C, the side that you don't trace is the one that's opposite from it. So when we say opposite side here, we're talking about the same thing. So what is the side that is opposite from angle B? Here's angle B. What side am I not tracing? AC. And what side is opposite from angle A? BC. So each triangle only has three sides. You know the hypotenuse, you know the opposite, so whatever side is remaining is adjacent. Now adjacent means next to. But for example, if I said what is the adjacent side to angle B, here's angle B. You know that the hypotenuse is AB. You know that the side opposite from B is AC. So the adjacent side is BC. What is the side that's adjacent to angle A? That's going to be AC. So, what are we using these ratios for? Well, there are three of them. So, like I said, as you've seen on your calculator where it says looks like sin, cos, and tan, it's actually sine, cosine, and tangent. And when we write it like this, you're always taking the sine, cosine, and tangent of an angle. Excuse me. So this here we say the sine of x. That's opposite over hypotenuse. The cosine of x is adjacent over hypotenuse. And the tangent of x is opposite over adjacent. So we have these three trig functions. Each of them is a ratio of two sides of the right triangle. The way that you can remember these is by the word SOHCAHTOA. SOHCAHTOA. Some people write it like this, as one long word. Some people write it with the S, C, and T capitalized, and then the different ratios side by side as fractions. However you want to remember it, as long as you commit SOHCAHTOA to memory, all of the trig becomes very easy. When you see it written like this is the sine of theta. Theta is just a name for an angle, just like, A, B, C. So in this case, what is the sine of A? So you have your picture here. Here's the right triangle. You should know either from your Pythagorean triples or by using the Pythagorean theorem that 3 squared plus 4 squared equals hypotenuse squared, which is 5. So now you have all three side lengths of the right triangle. So when I ask you for the sine of A, you find the angle A. SOHCAHTOA says that the sine is opposite over hypotenuse. So what is the opposite side from angle A? That's 4. What is the hypotenuse? That's always 5. So the sine of A in this particular example is 4 over 5. What's the cosine of A? Find A again. SOHCAHTOA. Cosine is adjacent over hypotenuse. Here's angle A. The adjacent side is the 3. The hypotenuse is still 5. So the cosine of A is 3 over 5. If you want to, you can label it. This is opposite. This is adjacent. And of course, this is always the hypotenuse. So when I ask you the tangent of A, here's A. SOHCAHTOA says the tangent is opposite over adjacent. So the tangent of A is going to be 4 over 3. All of these trig functions are expressed as ratios of the sides of a right triangle. Couple of hints. The word opposite means across from, and adjacent means next to. And in this course, at least, you will not find the trig function of a right angle, only the other acute angles. Notice how the other two angles have to be acute because all three angles, their sum in a triangle is 180 degrees. You already have a right angle. The other two have to be complementary. And then x is the degree measure of an angle. So, for example, over here when we say the sine of angle P, we want to know the sine of this angle. How do we know how to do that? Well, anytime you get a trig problem, you should write out SOHCAHTOA. It will tell you what to do. The sine is opposite over hypotenuse. So here's angle P. Go ahead and label the hypotenuse. Label the opposite. Label the adjacent. The sine of P is opposite over hypotenuse. So that's going to be, what is this length? It's a triple again. 5, 12, 13. Remember? Opposite over hypotenuse is 12 over 13. What's the cosine of P? That's adjacent over hypotenuse. So that's 5 over 13. Which leaves the tangent, which is opposite over adjacent, which is 12 over 5. Now, if you look at the other acute angle in the triangle, Q, and get those three trig ratios, watch what happens. The sine of Q is opposite over hypotenuse of here. So these are no longer the same. These have to be switched. Whatever is opposite of Q is going to be the 5. What's adjacent to Q is going to be the 12. So the sine of Q is opposite over hypotenuse, which is 5 over 13. The cosine of Q is adjacent over hypotenuse, which is 12 over 13. And then the tangent of Q is opposite over adjacent, which is 5 over 12. If you notice, when you look at the two different acute angles in the right triangle, the tangent of the two different angles is just the reciprocal. And then if you notice, the sine of P is the same as the cosine of Q, and the cosine of P is the same as the sine of Q. That will always work. Okay. Why don't you guys pause this and try example 2 on your own? Fill those out if you can. Okay. So what I'm going to do for this question is, first thing I'm going to do is label the missing angle. Obviously it's a 30, 60, 90. And if you want to, you can label the sides just kind of generically according to how your note said, which was the 1x, x root 3, and 2x. Here's the short leg, here's the long leg, here's the hypotenuse. If we're talking about the 60 degree angle, that's angle P, and I want to know the sine of 60, well, it's a trig problem, so I'm going to write out SOHCAHTOA. The sine of the 60 degree angle is going to be opposite over hypotenuse. Well, that's x root 3 over 2x. The x's are going to cancel out, which just equals root 3 over 2. I don't have to do anything further because I don't have any radicals in the denominator. I'm not taking the square root of a fraction or anything, so that's my answer, root 3 over 2. What's the cosine of 60? That's going to be adjacent over hypotenuse, so that's 1x over 2x. The x's cancel out. That's 1/2. And then what's the tangent of 60? Well, that's going to be x root 3. It's opposite over adjacent. X root 3 over x. The x's cancel out. That's just root 3 over 1, which is root 3. Now, if you remember what we just said in the previous example, we know that whatever the sine of 60 is going to be the cosine of 30. So that's root 3 over 2. You can feel free to double check according to the picture if you'd like. But I know that the sine of 30 is going to be whatever the cosine of 60 is, which is 1/2. And I know that the tangent of 30 is going to be the reciprocal of the tangent of 60. So that's going to be 1 over the square root of 3 times, I have to rationalize that. We can't have a radical on the bottom, on the denominator. So it's root 3 over root 3. That's root 3 over 3. Example 3, I want you to change this to 25. So we have a right triangle. Go ahead and draw your picture. We know that one of the angles is Q. We know that the other angle is V. We know that neither of those is going to be the right angle because we don't take trig functions of 90-degree angles, and we're taking the cosine of Q and the tangent of V. So we can just call the other angle, let's just call it R. Okay. So the cosine of Q is 7 over 25. SOHCAHTOA says that cosine is adjacent over hypotenuse. So the cosine of Q is going to be adjacent over hypotenuse. That's 7 over 25. This is also a triple, so this is going to be 24. So what is the tangent of V? The tangent of V is going to be opposite over adjacent, which is going to equal, what's opposite from V? 7. What's adjacent? 24. 7 over 24. Example 4, we have to find the sine of Q. This is not a right triangle, so what we're going to do is, because this is isosceles, I'm going to draw in an altitude, which is also going to be a median. So this is 6, and this is 6. This is also a multiple of the Pythagorean triple, 3, 4, 5, 6, 8, 10. I want the sine of Q. Feel free to write SOHCAHTOA again as many times as you want. The sine of Q is going to be opposite over hypotenuse. What is opposite from Q? That's 8. What is the hypotenuse? 10. So the sine of Q is 8 over 10. We want to reduce that, so that's going to be 4 over 5. So that's the end of the part 1 notes for 9.9, Intro to Trig. I hope that it wasn't too difficult, and I think it will help you out in the future if you could just make sure you remember SOHCAHTOA.